This next video, we will continue our look here at lesson 5 in module 3, where we are graphing quadratic functions. So in this exercise, we are asked to graph these functions and identify their key features. So it'll be like domain, range, max, mins, zeros, increasing, decreasing, end behavior, all that stuff. So we'll do all that. Okay. So for this situation right here, let's go ahead and start by finding the X-intercepts. So the X-intercepts are where our function is equal to 0. So we'll say 0 equals negative x plus 2 times x minus 5. And so since it's already factored, we can go ahead and set each of those factors equal to 0. So x plus 2 and x minus 5 equals 0. So you get x equals negative 2 and x equals 5. Okay, and we'll just kind of draw the axes in here in the center. Kind of missed the center there. I think this will be the center. There we go. Okay, plot the points. Negative 2, 1, 2, 3, 4, 5, 0, like that. Let's go ahead and find the y-intercept too. So that means putting 0 in for the x's here. So that'll be 2, that'll be negative 5, and negative 10 times negative 1 will be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the y-intercept. Okay, and then by symmetry here, let's see. So, and again, this is negative 2, and this is at 5. So that distance is 7. Okay, so the total distance here is 7. We want to go half of that, so 3.5. So 1, 2, 3.5 would be right here at 3 halves. That's where our vertex is. And we'll plug 3 over 2 in there. Which would be negative 3 over 2 plus 2, 3 over 2 minus 5. And so let's see here, it'll be 7 halves times negative 7 halves, which if we multiply there is going to be positive 49 fourths, which is 11.35. Sorry, 11.75. So 10, 11.75, so something like right up there is where our vertex will be roughly, because that would be 11 right there. And this would be like 12, so maybe a little bit higher, like that. Okay, those 2 points. And then for the y-intercept, we can also use symmetry here as well. So it is 1.5 blocks away, so a half and 1, we have a point right there. And then we can connect the dots. Okay. If you ever get stuck and you need to find some more points, you can always create like a little XY chart. Okay, and just pick some X values here, plug them in, and then get your matching Y values. Okay, typically I have my students put the vertex in the center, so in this case it was, the 3 halves, comma 11.75, and then I just have them pick 2 points before that. So like, it would be like good to do like, I don't know, like 1 and then 0, and then 2 points after, so like 2 and then 3, and plug those in and get the matching Y values too. Okay, so let's see here. The domain is negative infinity to infinity, right? Because it just keeps going to the left to the right. The range is going to be negative infinity to 12. Oh, no, 11.75, right? The highest point is 11.75. Oops, let me actually get there, so I should put there we go. We already found the zeros right there, so here are the, the zeros. Here's the y-intercept. Okay. Let's see here. The axis of symmetry is right here, so I mean we can write that down, I guess. Axis of symmetry is at x equals 1.5 or 3 halves if you like. Let's see here. The end behavior as x goes to infinity, f of x goes to negative infinity, right? Because we're going down as you go to the right. And as x goes to negative infinity, f of x goes to negative infinity as well, because again we're going down as you go to the left too. And then finally also our increasing. Where are we increasing here? Well, it's this part, right? We're going up from left to right on this section of the graph, the left section. So that's from negative infinity up to 3 halves. And we're decreasing, I'll just abbreviate for this one, from 3 halves to infinity. Okay, because we're going down from left to right there. Excuse me. All right, we'll do the second graph here in the next video.